So now that we've discussed the Java consumer functional interface, we're going to take a look at an example that combines it with the Java function functional interface. And it does this in the context of yet another example that can be found in the EX14 project in the FP folder in my modern Java GitHub repository. This particular example demonstrates how to combine the Java consumer and function functional interfaces in the context of the list interface and the ArrayList class that are found in the Java collection framework. This particular example uses consumer and function together to both print and sort thread objects that are defined in a list. And the particular list we're going to create here is going to be a list of thread objects named after our good friends, the Three Stooges, Larry, Curly, and Moe. So we name each of the threads Larry, Curly, and Moe respectively. And to combine them together into a list, we're going to take the Larry, Curly, and Moe threads, which are treated as an array by Java, and we're going to go ahead and create a fixed-sized but modifiable list using the arrays as list factory method. One of the things to note here is that this list is not only modifiable in the sense that you can change the contents of the specified array, but you can also rearrange the order of the elements by sorting it, as we see here in just a moment. The first thing we're going to do is we're going to use a method reference to a consumer to print the thread objects by their name. In particular, as you can see here, we're going to use the for-each method that's defined on the list interface, which ultimately comes from iterable, as we saw in the previous lesson on the Java consumer functional interface. And we're going to pass to it the system.out::println method reference, which will then, of course, cause for-each to print the contents of that list to the standard output. We're going to go one step further, however, in this example, and we're also going to apply the sort method defined on list in order to be able to sort the threads by name. And we do this by passing the thread : get name method reference, which is a function, to the comparing method, as you can see here. Now, we'll talk about comparing in just a moment, but comparator comparing is a method that can be used to impose a total ordering on the collection of thread objects by using the method reference passed to it, which in this case is thread : get name. And we'll talk about comparing here in just a second. So the comparing method is defined in the comparator interface as a static method, which means it can be given a default implementation, as we see here. And as I mentioned before, the purpose of comparing is to impose a total ordering on a collection of objects. And it does this by taking a function called keyEx as a parameter. And of course, the function is going to take a value, which is type t, and it's going to return a value, which is type u. So let's see how this gets used by the comparing method in the comparator interface. The first thing to note is that the thread : get name method reference, which is passed over here, is bound to the keyEx parameter. So that's how we get that method reference bound to the function that's passed to comparing. If you take a look at the implementation of comparing, you can see how it uses lambda expression syntax. And it's got two values, C1 and C2. Those, of course, are the two values that are being compared by sort. In this particular example, C1 and C2 are thread objects that sort is comparing in order to see how to order them within the list. The implementation here uses the function, which is keyEx, and calls its apply method. And the apply method will yield a string object that is then compared using the compare_to operator to determine the relationship between the two objects, in this case, the two threads. So what that does when compare_to is called, of course, is that returns the value 0 if the two objects have equal values. For example, if it's Curly and Curly that we're dealing with. If the first object is lexicographically less than the second one, a value that's less than 0 will be returned. So that would be, for example, Curly compared to Moe. And then if it turns out that the first object is greater than the second object, which would be the case with, for example, Moe and Larry, it'll return a value greater than 0. So that's how we do the relationship comparisons using the comparing function. If you think about what's really happening under the hood when we bind the thread getName method reference to the keyEx function. That is used in the manner shown on the slide, where it's as if we typed in C1, the first thread object, .getName, compare to C2, the second thread object, .getName. So that's what's happening here underneath the hood in order to perform the comparisons. So this particular example demonstrated how Java consumer and functional interfaces can be combined together along with other elements of the Java collection framework to provide a nice example to illustrate how these features work in combination. And we'll walk through the source code in more detail in the next part of this lesson.